Yeah.
Good morning, everybody. My name is Mazin Fad Al Joda. Today I'll be talking about molecular compounds, chapter 8, lesson 1. Vocabulary. Covalent bond are atoms that are held together by sharing electrons. Molecule is a neutral group of atoms joined together by covalent bonds. Diatomic molecule, a molecule that contains two atoms. Molecular compound is a compound composed of molecules. Molecular formula is the chemical formula of a molecular compound. Does anybody want to ask a question, anything? I would advise you to take a screenshot so you won't, so you can do it for the final exam. Do you take a screenshot or not?
Yes.
So key statements. Question number 1. What information does the molecular formula provide? Does anybody want to answer it?
Abdurrahman Diwan.
Go ahead.
A molecular formula shows how many atoms of each elementary substance contain.
So for example, what is the molecular formula of H3C5? So I want you to tell me how many atoms of hydrogen and how many atoms of carbon.
May I answer?
Okay.
Anybody else?
Okay. I want to this question here, what is the molecular formula of? You have to write the name of the molecular compound, okay? Okay, but if you ask what is who can explain the molecular formula of مثلا H3C5 here, this is not right. You can say C5H10, okay, C5. You cannot start with hydrogen. You must, okay?
Why, teacher? It could be hydrocarbon. Hydrocarbon, teacher.
Hydrocarbon, we always, when we write the molecular formula for hydrocarbon molecule, you have to start with carbon at first, okay? Okay. And there is no molecular formula with 5 carbon atom and 3 hydrogen atom. You have to choose a right molecular formula. Okay. Okay. So let's change this molecular formula into C5H10. C5H10. Okay.
So
Yes.
it's C5.
That's it, my answer.
We know that there are 5 carbons that the molecular formula contains and 10 hydrogen atoms. Does anybody have any questions about it or nobody? Okay.
Question for you or the teacher. Why can't we start with the hydrogen?
Hydrogen is a terminal atom always in the molecules, okay? We have to start with the carbon. It is the central
What
atom.
about when we said H2O? We started with hydrogen.
Okay, H2O, it's different case because, okay, it's a different case. Okay, hydrocarbons always start with carbon when you write the molecular formula. Okay?
Okay, thank you, teacher.
So, okay, key question number 2. What representative units define molecular compounds and ionic compounds? The answer is the representative unit of a molecular compound is a molecule, while for an ionic compound, the representative unit is a formula unit. Test your understanding. What is the difference between formula unit and a molecule? Formula unit is the lowest whole number ratio of ions in an ionic compound. Molecule is a neutral group of atoms joined together by covalent bonds. This is lesson check 8.1. Now I'm going to ask you questions to test your understanding on this lesson, and I would very much appreciate it if all hands were raised. Lesson check 8.1. Question number 1. Identify what information does a molecular formula provide? Who wants to answer?
Abdurrahman Jayban.
Go ahead.
Okay. So I've answered this question, which was a molecular formula shows how many atoms of each element a substance contains.
Thank you very much. Now, question
You're more
number
than
2.
welcome.
Compare. How is the representative unit of a molecular compound different from the representative unit of an ionic compound?
May I answer it?
We need somebody other than Abdurrahman Jayban. Okay, go ahead. We don't want to waste time.
Okay. So the representative unit of a molecular compound is a molecule. For an ionic compound, the representative unit is a formula unit.
Yeah, thank you very much.
You're more than welcome.
So now we want to ask question number 3. Identify what are the only elements that exist in nature as uncombined elements. What term is used to describe such elements?
May I answer?
Yes, of course.
Yes. The noble gases اللي
Of course.
هو helium, neon, argon, krypton.
Yeah, but what do we use the term to describe them?
Noble
What term is
gases,
used?
brother.
Yes, that's the
monatomic.
noble gas.
Monatomic.
Yeah,
Monatomic.
thank you very much.
You're more than welcome.
Question number 4, compare and contrast. Describe how the molecule whose formula is NO is different from the molecule whose formula is N2O.
May I
May I
answer?
answer?
ترك المجد.
كفو مازن. So nitrogen monoxide has only one nitrogen atom, while nitrogen dioxide has 2 nitrogen atoms.
Thank you very much.
Dinitrogen oxide. The first one, nitrogen monoxide. The second one, dinitrogen monoxide. Okay?
Okay. Question number 5. Apply concepts. Give an example of a diatomic molecule found in Earth's atmosphere.
May I
Abdurrahman Jayban.
answer?
Yeah, of course.
Who?
Abdurrahman Jayban.
Okay. 2 examples are oxygen and nitrogen.
Thank you very much. Question
You're
number 6. Identify what information does a molecular structure give? Nobody's in question number 6.
No, I'd like to answer.
Okay, go ahead and answer it.
Okay. So a molecule's molecular structure shows the arrangement of various atoms in space. And it also shows which atoms are covalently bonded to one another.
Yeah, thank you very much.
Excellent, Mazen, excellent, Abdurrahman.
And this is the answers for the lesson check that we just answered. So if you want to take a screenshot so you can do it on your notebook when the time comes for the final exam, it would be very much advised. Did you take your screenshots?
Yes.
Yeah.
Thank you, Mazen.
Thank you, Mazen. Thank you, Mazen.
You're welcome, teacher. I hope you find it very useful and informative. And thank you very much for my fellow colleagues and my beloved facilitator, Mr. Maher, who supervised this presentation. Thank you very much for giving us this time.
Thank you. Okay, let's just continue our lesson with Turki al-Majhad.
Okay. Can you guys see the screen?
Yeah.
So the nature of covalent bonding.
Before you start your presentation, please give us a quick hint about what you are going to talk about.
Okay, so today I'll be talking about the nature of covalent bonding, which is going in depth on what Mazen has previously said about the molecular bonds and so on. So this is done by me, Turki al-Majhad, and supervised by Mr. Maher. So the terms and vocabularies include 1. The single covalent bond, which is 2 atoms held together by sharing 1 pair of electrons. Number 2, structural formula, which represents the covalent bonds as dashes and shows the arrangement of covalently bonded atoms. Unshared pair is a pair of valence electrons that is not shared between atoms. Double covalent bond is a bond that involves two shared pairs of electrons. Triple covalent bonds is a bond formed by sharing three pairs of electrons. Now, the continuation of the vocabulary includes the coordinated covalent bond, which is a covalent bond in which one atom contributes both bonding electrons. Polyatomic ions is a tightly bound group of atoms that have a positive or negative charge and behave as a unit. Bond dissociation energy is the energy required to break the bond between two covalently bonded atoms. Resonance structures are structures that occur when it is possible to draw two or more valid electron dot structures that have the same number of electron pairs for a molecule or ion. Now, moving on to the key statements. In covalent bonds, electron sharing usually occurs so that atoms attain the electron configuration of noble gases. Atoms from double or triple covalent bonds act if they can attain a noble gas structure by sharing two or three pairs of valence electrons. In a coordinated covalent bond, the shared electron pair comes from one of the bonding atoms. The octet rule cannot be satisfied in molecules whose total whole number of valence electrons is an odd number. There are also molecules in which an atom has less or more than a complete octet of valence electrons. Continuing the key statements, a large bond of dissociation energy corresponds to a strong covalent bond. Chemists use resonance structures to envision the bonding in molecules that cannot be adequately described by a single covalent structural formula. And that is the vocabulary and the key statements of Chapter 8, Lesson 2. Thank you.
Welcome.
Thank you very much.
Welcome. Thank you. Thank you, Mr.
Okay. Mr. Can you please give me permission for
Yeah, you have the
start
permission.
to share screen?
Yeah, you
Thank
have
you so much. Okay, can you see, guys?
Yeah, start.
Okay. So, bonding theory by Faisal Abdullah and Mubarak Al-Hussein, supervised by Mr. Mahal Abu Khalil. Okay, Mr. So let's start with the vocabulary words. Okay, so let's start with the molecular orbitals. Molecular orbitals are orbitals that apply to the entire molecule.
Bonding orbital is a molecular orbital that can be occupied by two electrons of a covalent bond.
Sigma bond is when two atomic orbitals combine to form a molecular orbital that is symmetrical around the axis connecting to atomic nuclei.
Pi bond, a covalent bond in which the bonding electrons.
Pi bond.
Pi bond, a covalent bond in which the bonding electrons are most likely to be found in SO-SAID. Shaped regions above and below the bond axis of the bonded atoms.
Okay. Tetrahedral angle is a bond angle of 109.5 degrees that results when a central forms for four bonds directed towards the center. Forms a four bond direct toward the center of a regular tetrahedron.
VCEPR theory.
Yes.
Huh?
Visible.
State that the repulsion between the electron pairs stay as far apart as possible.
Yeah. Hybridization, the mixing of several atomic orbitals to form the same total number of equivalent hybrid orbitals. Okay, so let's start with our first key question. How are atomic and molecular orbitals related? Who can answer this question?
Question number one. Who can answer?
Can I, Faisal?
Okay, I was talking, but I was on mute. I'm sorry.
Question one. How are atomic and molecular orbital related? Just as an atomic orbital belongs to a particular atom, a molecular orbital belongs to a molecule as a whole.
You think Abdullah that was the right answer. Okay, key question 2.
May I answer?
What do scientists use the VSEPR theory for? We need someone to answer it, please.
Jeban.
Abdelmal Jeban.
Okay, thank you. So, in order to explain the three-dimensional shape of molecules, scientists use valence shell electron pair repulsion theory, which is also known as the VSEPR theory.
Great answer, Abdulrahman Jeban.
Thank you.
You're welcome. Let me just show you the answer. Okay, so question 3. Key question 3. In what ways is orbital hybridization useful in describing molecules?
Can I answer, Faisal?
Who would like to answer?
Can I answer?
Faisal. Naif Anizi.
Okay, orbital hybridization provides information about both molecular bonds and molecular shape.
Great answer. Thank you, Naif.
Thank you to Faisal.
Thank you so much. Thank you so much for attending our presentation. Thank you so much, guys. Thank you, Mr.
Thank you, Mr. Maher, for letting us.
Okay.
Thank you so much.
Barak in Faisal for this amazing presentation.
Faisal,
Thank you.
thank you very much. That's it for today. Okay. See you tomorrow. See you tomorrow, inshallah. Okay.
Thank you very much, teacher.
Goodbye.
Mr.
Yes.
Thank you for this delicious
Will we get the full mark in participation?